Hello. This video explains how to create a script program to drive and sense boundary scan pins and pin groups on a target printed circuit board. We will continue with the same project CTNet starter from the previous videos, and we'll be using the same target PCB. Scripts are particularly useful in testing non-boundary scan components that are accessible from boundary scan pins. Just to recap, the target PCB is a Xilinx evaluation board that has 4 JTAG devices in one chain, and it is driven by the channel A from an on-tap USB controller, and there are multiple LEDs, as can be seen here, and the script program that we make will just exercise these LEDs to demonstrate the capabilities of script programming and how to get started with it. So the first thing we'll do is go to the System menu, open an existing project, the one that we've been working on, and we will bring that up. Here's the JTAG chain that we had defined. Test data in at U4 and test data out at U1, which is an FPGA. Okay, so with that open, we can now open the System menu again and simply select Add Script Program, and we will call the program set underscore LEDs.txt, and the .txt extension will let Circuit Trace know that we're opening a script program, and the project folder is the one that we're currently in, and we're going to copy from the settings from this program which we set up earlier. So when we do this, we're going to copy all of the chain definitions in power and ground assignments, guards, and that type of thing, which will save us, and this will save us the trouble of redoing that. So we'll click OK. Okay, and so when we do it, if we now look at our nets, we see that all of the power and ground settings have been copied through, and we are ready to put some text in the script page, and to do that, what we're going to do is simply copy some text, copy and paste some existing text rather than fill out the program. Okay, so I have grabbed some text, paste it in here, and what we'll do is just save it first. Save it as in the scripts program, in the scripts folder. We'll save it. It's already there, but we'll resave it. Okay, so just to explain the script program, double slashes are comments, precede a comment. Variables can be defined as integers or strings. So in this case, we have integer x. Pins are assigned as LED 74, for example, is assigned to this net on the board. And Circuit Trace will then look for a boundary scan pin on the net to drive and sense. Here, LED 78 is directly assigned to U3 pin 78. And then LED 76 and 77 are assigned to nets. And then here, pins LEDs is a pin group, and we simply give this a name, and then we list the pins that are going to be in the pin group. And then the main section where the program executes has these built-in instructions, for example, drive low, and then a list of pins it wants to drive low, drive high, Drive high, a list of these pins. DZ is a drive to a high impedance, tri-state. And then we come down to a for loop. So this is some flow control. And you can have functions that you can call. You can have while loops, for loops, and other types of flow control. So this will execute for x equals 0 to x less than or equal to 45. It will assign to the LEDs pin group the value on x. So that x will get mapped onto LEDs. And then drive group, DG, will put the value out on the boundary scan, respective boundary scan pins. And then there's a message, say LEDs equal to whatever the LEDs are equal to. So we can run this. If I run it right now, it's going to run pretty quickly. So what we'll do is we'll take a look at single stepping and what that can do. The other thing, when we're single stepping, we're going to want to look at particular variables, and we can do that by just clicking on them. For example, right now, x is equal to 46 and LEDs is 45 after running through the program. So let's say we want to stop and take a look what's going on. Maybe we're debugging the program. So we will set a breakpoint, and then we can just run the program and it will stop at the breakpoint. Then as we step through it, well, x is equal to 0. So at this point, all of the LEDs are off. Then as we continue to step, x is 1, now LEDs is 1. So now one LED is turned on. Stepping through, now the next LED with x equal to 2 is turned on. Now with x equal to 3, 2 LEDs, the first and the second, are turned on. So this is the way it would go, and you can debug your programs this way. So, and then we can toggle the breakpoint off and then run the program, and it will run through. There are a few things that you can do that you should be aware of. And for example, in this case, the program is run from U3, and other devices in the chain could be put in bypass, for example. So if you go into the chain, select a device, for example, U2, you could go to its list of opcodes, and you could set bypass, for example, or X-test, depending on what you want to do. And when you do that, though, you should go back to JTAG setup and click OK, so that you redefine the chain and what's going on in the chain and what instructions are going to be used during the time when the script is running and driving pins. So that's a quick look at script programming. It can be quite powerful. You can edit the program right here. And it's interpreted. There's no compiling, so you just make the changes that you need and run it. You can set breakpoints, as we saw. You can call functions. There's quite a bit of flow control capability involved. And it's C-like, a little bit like JavaScript, but it's very simple. And so we're going to wrap it up here. And that will be it for script programming.